So limits at infinity. Limits at infinity essentially are going to give us slant asymptotes and horizontal asymptotes. So what we're most familiar with is these horizontal asymptotes. So what's happening as to the function, the y values of this function, as x gets really, really big? So if we take a look at this fraction here, this rational expression, as x gets big, what's going to happen to the value of this calculation? Well, at really large values of x, this plus 2 and minus 1 really aren't very significant because x squared, 10 billion squared minus 1 is that minus 1 has very little effect. Okay, if I have an x squared here, 10 billion squared plus 2, that plus 2 has very little effect. Now, the same thing here with this x value, because if we compare 10 billion squared with just 10 billion, well, 10 billion squared is really, really, really big. Okay, so what ends up happening is these terms tend to be insignificant. So as x gets large, these terms here, this one, and this one, become insignificant. And we end up, this graph starts to behave like 2x squared over 1x squared. Okay, so basically 2x squared over 1x squared ends up being equal to 2. So as x gets large, we can ignore these terms and just look at this ratio, 2x squared divided by x squared, and we get this ratio equal to 2. So what ends up happening then is this graph then starts getting closer and closer to this value of y equals 2. And we end up with a horizontal asymptote at that value. So this is how limits can help us out. And we kind of knew this before, but the limits now are formally letting us establish that this limit is equal to 2, and we get a horizontal asymptote at 2. For this graph here, the limits allows us to also deal with vertical asymptotes. Okay, so if we take a look at this graph here, we're going to end up, we can simplify these things here. So we take away these squares. We end up with the limit as x goes to 1 of 2x plus 1 over x minus 1. So we're going to end up going towards 1. So we end up with 4 divided by 0 essentially. Now dividing by 0 is very tricky because we know that it depends on which side of 0 we come from. So in this case here, as a one-sided limit, we have to say this does not exist. Sorry, as a two-sided limit, it does not exist. Okay, because we end up going up the vertical asymptote from one side, and we go down the vertical asymptote from the other side. So as a two-sided limit, they're going to two different places. Now, as a one-sided limit, we can actually do this. So I'm going to split this up. So the limit as x goes to 1 from the positive side of our f of x, so this is 2x plus 1 over x minus 1. Okay, from the positive side, we basically end up with 4 over 0 from the positive side. Well, that's equal to positive infinity. Okay, so as a one-sided limit, it exists as positive infinity. From the other side, the limit as x goes to 1 from the negative side of that same function. From the negative side, as we go to 1, we're going to go to 0, but from the negative side is going to be the negative side of 0, which then means we're going to end up at negative infinity. So as a two-sided limit, it doesn't exist, but as a one-sided limit, it's going up to infinity from one side and down to infinity from the other side. So when we look at graphs, they're a good way looking at graphs is a really good way of understanding limits because we can see where the graph is going. So if we can actually see the graph and do limits from pictures, that's the best way to do it. Okay. Now we're going to have to develop some algebraic rules to do this as well, but when we can, we try to do this with pictures. So to do limits formally, we're going to write this limit notation. And when we have left-hand limits and right-hand limits, so this is a right-hand limit and we have a left-hand limit, if they are both equal, we can say that the two-sided limit exists. Okay, so that we have a limit at a in this case. So then we end up saying the limit as x goes to a, when there's no plus or minus, it indicates a two-sided limit. We can say that f of x is equal to L. Okay, in this case here, when we have the left-hand limit is not equal to the right-hand limit here is not equal to the left-hand limit here, as we approach the same value a, then we have to say that the limit does not exist at a as a two-sided limit. Okay,